Hello. What we're going to look at today is we're going to look at an introduction to chemical calculations. And what we're going to focus on is working out the formula mass of different chemicals. So we're going to use the chemical formula to work out what mass that will have. And there are two ways in which this can be asked. You could be asked for the relative formula mass, which doesn't have units, or the gram formula mass, GFM, sometimes called the molar mass, which has units of grams. So depending on which one of these you're asked for, you'll either put units on it, grams, or you'll have no units on it. And if that's the case, no matter which one of those, you take the same approach. Now, before we get into calculating this, we need to understand how to use chemical formula and what chemical formula represent. So we're going to do 3 examples, and we're going to show how to understand the formula, and then for each one, we're going to show you how to calculate the formula mass. So the 3 chemicals, the first one is calcium fluoride. Calcium fluoride, and it has the formula CaF2. Whenever we are using formula, we need to know how many elements there are and how many of each type of element there is. Now, the way you can determine how many types of element there are is by looking for capital letters. So every time we have a capital letter, we have the start of a new element. So in this one, we've got a capital C, we've got a capital F. And it's C small a, which is calcium, capital F for fluorine. So we know we've got 2 elements. We have got calcium and we have got fluorine. The next thing, before we can do anything, is we need to know what happens in terms of how many of each type there are. And the way that we do this is we look after the symbol. So we look after the symbol here and here. Now fluorine is quite easy. We've got an F there and it's got a number 2. So that tells us we've got 2 atoms of that. Now calcium, there's no number. And if there's no number, that means it's 1 atom. So this is our starting point in each case. We need to find out how many different types of element, and for that, you're looking for the capital letters, and then you're going to use the numbers beside the symbols to work out how many of each type. If there's no number, like we have here for calcium, it's 1. Otherwise, if there is a number, that is the number. So for fluorine here we've got 2, so that gives us 2 atoms. Now the situation does get a bit more complicated whenever we introduce brackets into a formula, which you will sometimes see. So here is a formula that has brackets in it. Three. So here, again, for working out the number of elements, we are looking for capital letters. So that's our starting point. So we've got a capital A, we've got a capital N, and we've got a capital O. So that means our first element is Al, our second element is N, and our third element is oxygen. Now we're going to use our normal rules to see how many of each type of atom there are. So For aluminium, we've got no number after it. So that means no number, so there's only one atom. Now, inside the bracket, we've got a nitrogen with no number. We've got an N with no number. So that would mean that there's 1. And then we've got an oxygen that's got a 3. So that would mean there's 3. So we'll start off 1, and for oxygen, 3. And that's coming from the 3 here, and the fact there's no number here, and for aluminium, the fact there's no number. But we've got a bracket here, and that's going to make things a bit more complicated. And when we've got a bracket, whatever number is outside the bracket, we multiply the things inside the bracket. So nitrogen, there was 1, and then there's a 3 outside the bracket, so it's 1 multiplied by 3, which equals 3. For oxygen, 3 inside, 3 outside, so we multiply it by 3, and that equals 9. So those are our rules for working out what elements are inside an atom and how many. What elements are inside a formula and how many of each type of atom. So when we don't have brackets, all we're doing is looking for the numbers after symbols, and remember, no symbol means 1. For brackets, we look at the symbols and do the same thing as before, but anything inside a bracket, so here we had 1, gets multiplied by whatever number is outside the bracket. So it's 1 times 3, and then for oxygen we had 3 inside, multiplied by 3 on the outside, that gives us 9. And that is going to be the basis for determining any formula mass. It's going to always start with the formula. What are the elements inside it? How many of each type are there? Okay, so now we're going to look at how do we actually work out mass. So formula mass. Now for doing this, you need a chemical formula. You will need a calculator, and you will need the National 5 data booklet. Specifically, you will be using page 7 of that data booklet. Now the page looks like this. So data booklet like this, and the column, so you've got the symbols for the element or the second column, and you've got 2 rows of that, and then the relative atomic mass, that's what we're going to be looking at. So you're going to be looking at the symbol and the relative atomic mass, and that's what you're going to use. So we're going to start with calcium fluoride again. So we know that we have got calcium and we know we've got fluorine. From here, we know that there's 1 of those. From here, we know that there is 2 of them. So we've got 1 calcium and 2 fluorines. What we need to do, right, so that's number. Then what we need to do is look up the mass. And the mass is on page 7 in the 3rd column. So whenever I look it up, I see that calcium is 40 and fluorine is 19. And the next thing we do is we multiply. So we multiply these 2 numbers together. And what we get, 40 times 1 is 40. 2 times 19 is 38. And the final step is to add the two numbers together. 40 plus 38 gives us 78. And that is our formula mass. Now, if it is relative mass, we would just have 78. However, if it is molar mass, right? Molar mass or gram formula mass, it would be 78 grams. The only difference is putting that symbol in. So we do find out what elements are in, how many of each type of atom, look up the mass in the table, multiply the row, and then add them together. And we put grams on it if we're asked for the molar mass or the gram formula mass. If we're just asked for the formula mass or the relative formula mass, we don't need units. We're going to do two more examples of that. So the next one, example 2, is going to be ammonium hydroxide. So we're going to look for our capital letters. We've got an N, we've got an H, we've got an O, we've got an H. So there are different ways you can do this. You could say we've got H here and H here and count them together, or you can treat them individually. What I'm going to do is I'm going to treat them individually. So I've got nitrogen, N, I've got H, I've got oxygen, and then I've got another H. So I'm going to look after each one for any numbers. So nitrogen, no number, so that means there's one of them. Hydrogen here, oh, we've got 4, so that's times 4. Oxygen, no number, so that's a 1. And this final hydrogen, that has no number, so that's just times 1. Then what I need to do is look up the masses from page 7 in the data booklet. I see that nitrogen is 14, hydrogen is 1, oxygen is 16, and hydrogen is 1. And then I multiply these numbers together, and that gives me 14, 4, 16, and 1. And the final thing I do is I add them all together. So 16 plus 4 is 20, plus 14 is 34, plus 1 is 35. Now if I'm just asked for the formula mass, then it's 35. And again, if I was asked for the gram or molar mass, that is 35 grams. We will do one final example, and this is going to be one that involves brackets. So we're going to look at that one we looked at the start, aluminium nitrate. Okay, so we're going to start looking for capital letters. We've got one here, one here, one here. So we've got aluminium, we've got nitrogen, and we've got oxygen. Now we're going to look for how many of each type there are. So aluminium, no number after it, so there's one of it. Nitrogen, now inside the bracket, there's no number after it. No number here. but there's a 3 after that, so that is 1 times 3. So that's times 3. And then oxygen, we've got 3 here and 3 outside, so that is 3 times 3, which adds up to a total of times 9. We've got 9 oxygen, 3 nitrogen, and 1 aluminium. Now we look at the data booklet for what the mass is. The mass of aluminium is 27. The mass of nitrogen is 14. And the mass of oxygen is 16. And just like before, we multiply. So 1 times 27, 3 times 14 is 42, and 9 times 16, 144, I think. Might use my calculator on this one. Yeah, that's 144. And what we do is we add them together. So what we have, 69 plus 144, which gives us 213. Which again, if it's just the formula mass, that's that. But if we're asked for the molar or the gram formula mass, it's going to be 213 grams. So that was a brief introduction to how to do this. What I'm going to show you is just another way to set these types of questions out that some people use, and you might see used in maybe some textbooks. So what I'll do is I will do the ammonium. Now what some people do is they do a system where they, from each element, they say, okay, there's 1 hydrogen, so that's 1. And then they look up the mass, and the mass of hydrogen is 1. So that equals 1. Then they move along to the next one. Well, there's 1 oxygen, and each oxygen is 16. So that equals 16. Then these hydrogens, there are 4 of them, and each hydrogen weighs 1. So that's 4. And then finally, that nitrogen. There's 1 of them, and the mass of a nitrogen is 14, which equals 14. And then what they would do is find a pen that works, add them together like that, and that is 35. So that's just a different way of setting it out. So some people find that that looks nicer than that way. It just depends whichever way you prefer. So that's them both side by side there. Both are exactly, get you the same answer, it's just different ways of setting it out. So it's just up to you which one you prefer. So that was our introduction to how to work out formula mass and gram formula mass. So thank you for your attention.